In this video we shall see concepts that we saw in the hub video being applied to blackjack. Recall that n choose r is given by the following formula. This can be used to calculate probabilities. The number of possible two-card hands in blackjack is 52 choose 2, which makes sense as you have 52 choices for the first card and 51 for the second, but you count each possibility twice as the order doesn't matter. The probability of getting a blackjack is the number of ways of actually getting one divided by the number of total possible outcomes. In this case, 4 choose 1 aces times 16 choose 1 cards with value 10 divided by 52 choose 2 to give a probability of approximately 4.83%. We can also look at slightly more complicated examples. To have a starting hand of 20, this can be done through 2 tens or faces, as well as a 9 and an ace. There are 16 choose 2 ways of getting the former and 4 choose 1 times 4 choose 1 ways of getting the latter. We again divide by the total number of outcomes to obtain a probability of approximately 10.26%, which is high compared to other outcomes due to the abundance of cards with value 10. Now let's consider something different again. You already have a hand with a king and a 6 and the dealer has a 10. What's the probability that you go bust if you hit and take another card? Well, you can go bust by drawing a 6, a 7, an 8, a 9 or a value 10 card, so we sum these possibilities and divide by the total number of outcomes, in this case 49, as there are 49 cards left in the deck. So this is a probability of around 59%. These clearly are not particularly good odds, but the question remains, would standing be a better option in this scenario? Well, if you do and the dealer's next card is a 7 to an ace, you've already lost, and there's a 61% chance of this happening. And as there are other ways for the dealer to obtain 7 to 11, it transpires that in this case standing is not a good option. These sorts of plays on unfavourable hands are often those that are least well understood. A decent rule of thumb is that if you have a hard 12 to 16, then stand if the dealer has a low card and hit if the dealer has a high card. Some exceptions to this are that if you have a 12 on a dealer's 2 or 3, then hit, and in fact the previous example was so bad that if possible you should surrender. So imagine another scenario. This time you have an ace and a 7, making a soft 18, and the dealer has a 10 card, say maybe a queen or something. Many people would reason that 18 is a good score and you risk making it worse, especially if you draw an 8 for example, which turns the soft 18 into a hard 16. But again, if the dealer gets a 9, a 10 or an ace, they beat you immediately. And even if they don't get this, there are a number of possible combinations that they can get that will still allow them to beat you. If their second card's a 6, there are 12 out of 48 cards left which can beat your score immediately. If their second card's between 2 and 5, there are 11 out of 48. Hence, without even including winning card combinations of more than 3 cards, or even what the dealer does on hitting 17, the dealer already has more than a 54% chance of beating you. The maths behind splitting is not considered in this video, but another thing that we will consider is the maths of insurance. So maybe if you've got a 9 and an 8 and the dealer has an ace, should you take the 2 to 1 insurance side bet that the dealer has blackjack? Try pausing the video and calculating this one for yourself. Okay, as this is a 2 to 1 side bet, if you want a return on your money, you need to win this at least half the time. Now the dealer needs a 10 value card. 16 of the remaining 49 cards have this, which is less than a third of the time. Hence, without sneaky strategies such as card counting, you will not get a return on your money and you should not in general take insurance. The same goes for most other side bets too. Here's another tip. Never play at a table where blackjack pays 6 to 5 instead of 3 to 2. To see why, look at what happens when you spend £100 playing. On average, you would expect £4.83 of this original sum of money to go towards hands where you get blackjack. Now, if blackjack plays 3 to 2, you clearly get more money than for 6 to 5. In fact, around £1.45 more. So, on a 6 to 5 table, for every £100 you spend, you lose an average of an additional £1.45. Given that you'd typically expect to lose around 50 pence per hand on average, increasing this by an additional £1.45 is not a good move. And lastly, I leave you with a few questions. Firstly, what is the probability of having a starting hand of 19 or better? Second, you have a jack and a 5 and the dealer has a 9. What is the probability that you bust if you hit? And thirdly, if you have two tens and the dealer has an ace, is an insurance a better or worse bet than the example given in this video? Also, insurance is normally a 2-to-1 side bet. What odds would you require to take insurance in this scenario? If you want to see the answers to these questions, feel free to click on the chips in the bottom right corner. If you want an easy to memorise strategy, feel free to click on the deck of cards, or if you want to see the rules again, that can be found on the top left tab. Alternatively, if you're sick of hearing my voice already, feel free to click somewhere near the middle of the screen if you want to return to the hub video.